So hi guys, for this example, we have here our resistors connected in parallel. So we have two resistors. So our first resistor R1 with a value of 2 ohms. Then our second resistor R2 with a value of 2 ohms as well. Then both of these resistors are connected to a constant voltage source with a value of 8 volts. So now for this example, we want to compute first for the equivalent resistance of the circuit. Second, we want to compute the current that will run through the circuit. And last is the potential drop across each resistor. Okay, so now what we want to compute is for the equivalent resistance given this two resistors connected in parallel. So we know from our previous discussion that we can get the equivalent resistance using this expression. So 1 over R equivalent is equal to 1 over R1 plus 1 over R2 plus 1 over R3 and so and so. So given that this is your R1, then this is your R2. So what we can do is to use these two resistors. So 1 over R equivalent for this circuit diagram. So this is equal to 1 over R1 plus 1 over R2. So we can re-express the right-hand side of this equation. So therefore, we have R2 plus R1 over R1 times R2. But please take note that this expression is still 1 over R equivalent. What we want to get is R equivalent. So in order to get that, we can get the reciprocal of this expression. So this is just equal. So R equivalent is equal to R1 times R2 over R2 plus R1. We can now substitute the given values of R1 and R2. So we have 2 ohms times 2 ohms over 2 ohms plus 2 ohms. And we know that this is just equal to 1 ohm. So very easy. So therefore, we can simplify this equation or this circuit diagram by rewriting it as this. So this two resistors connected in parallel is equivalent to this circuit connected to a certain 8 volts voltage source with the equivalent resistance value of 1 ohm. So they are equivalent. So next, we want to calculate the current that will pass through this circuit. So we know from our V is equal to IR formula that your I is equal to V over R. So we will use this formula wherein your V is your constant voltage source here, which is just equal to 8 volts over R, which is your R equivalent for this case. So this is equal to 1 ohm. So thus the value for I is just 8 amperes. Now, this current refers to the current before before it passes through your node. Because take note that at this junction, at node, your current I will be divided into two. So the current that will pass through your first resistor, let's say, let's call this one I1. Then the current that will pass through your second resistor R2. So let's call this one I2. So if you want to get I1 and I2, what we can do is we can use the fact that voltage is the same for both resistors. So both R1 and R2 have the same voltage value or potential drop. So thus the potential drop for R1, let's say that's V1. So this is just equal to 8 volts, and your V2 has a potential drop of 8 volts as well. So we can calculate your I1 using this value of V1 here. So your I1 is equal to V over R1 or V1 over R1. So this is equal to 8 volts over 2 ohms. So this is equal to 4 amperes. So same with your I2. So your I2 is equal to V2 over R2. So that is just 8 volts over 2 ohms. So this is also equal to 4 amperes.